though I myself is very much using an IT application in agriculture, but so I have made my own effort in compiling the information related to the engineering technologies which have been adopted in agriculture for the various crop production, crop protection, and post-harvest technologies also. Okay, so I hope that the engineering students of the different departments are here, so that it is quite useful for them. And so I will actually now with this brief remark, I will start my presentation and I will share my PPT uh, with this gathering. Uh, is it visible?
Yes, sir, it's visible. It's clear, sir.
Okay. And I am moving my slides. Please just respond if you can see those change in the slide movements. Are the slides moving, madam?
So it's clear, sir.
Slides are moving now?
Yes, sir, they are moving. Yes.
Okay, okay. Thank you. Okay, so so good morning to all, and I welcome you for a small presentation on the role of engineers, technology in agriculture. And so I start with a question that do we need engineers in agriculture? Well, of course, at the outset, the beginning of the agriculture, when actually the human, before the human civilization, when human beings started understanding the cultivation of the crops, which they started with the zooming cultivation or the shifting cultivation. Of course, there was no need of an engineers, because you know that the zooming or shifting cultivation basically involves simply moving from one place to another, and sowing the seeds in a natural condition, and whatever the crop comes, so the man used to harvest and use it, and then move to the next place, cut off these the trees, and again throw these seeds there, and then start moving. And we can see this kind of a zooming or the shifting cultivation even today in the northeastern parts of India, where so northeastern part of India, where there's still some of the tribes follow this. But however, once the man started settling down in one place, and then started intensively growing the crops, then of course the engineering, the part has surely stepped in. We have the evidence of the first use of the agricultural engineering through the development of the irrigation system in a large scale in agriculture in the Nile and Euphrates rivers, well before the 2000 years, in fact, before Christ. And we also see the large irrigation structures even now in the Balochistan and even in India, whether different parts of India before the Christian era. So what it shows is that since then, so in fact, the engineering or engineers, the section, engineering section and agriculture are inseparable. Okay, these are some of the that I have shown, which might be a painting or something, but which has been constructed based on the existing evidences in the form of the old archaeological evidences, where either formation of the canals it must be, or the deviation slope, or the main canal system, subsidiary tributaries. So all these things, without an engineering knowledge, so this cannot actually happen. So with this small, the brief historical background, so we will now move on to the next thing is that when man started using the implements, especially in agriculture, for the disturbing the soil in terms of plowing the soil, sowing the seeds, and then harvesting the plants, and as well as the transportation of these agriculture produce, they're all he's bound to use the certain structures, and the structures which have been made in such a way with a definite angle and the dimensions, which always need the engineering in this kind of the structure. You can see there is a plow. The plow has to be designed in a particular angle so that it plows the soil at a required depth, not too deep, not too shallow, so that which is quite uh, what is called provides a congenial condition for the seed to germinate, grow, and produce a good yield. In fact, and also I told you that during the transportation also the man started using the old bullock carts that we even now see with the wheels, okay, and those kinds of designs and all is essentially need the engineering, the minds in designing those things. So, but however, those agricultural the practices that the we started following it has now made a very drastic change as the industrialization started happening. So you know that since the era of industrialization, when the machines, machineries, farm, I mean the power, all these things have started getting into it. Then that makes also the inroads into the agriculture, and due to the growing human population, land size started shrinking, but feeding mouths are increasing. So as a result, so there is a challenge for us to actually grow more and more food with the shrinking land. So which only happens with the only either the improving the crop varieties and also through the mechanization. So this is possible, and as a result, it was only in certain section of the engineer which used to be taking part in agriculture, such as the civil and mechanical earlier. But as there is an more and more branching started happening in engineering, and all those branches also started contributing a lot significantly for the development of agriculture. Agriculture, you know that from earlier it used to be of a sustainable way, so just for feeding their family and then just selling it off through barter system in the earlier days. But now agriculture has completely changed the dimension through a commercial way, and the only the agriculture now has been taken up as a business, as an industry. So in that, so it is possible with the lot of engineering interventions into this. So I have, for the convenient, so divided the branches of the engineering probably. So this is what I feel also is present in engineering. The degree program as a civil, mechanical, electrical, electronics, computer applications. Okay, under this, how these have actually contributed in the agriculture in the various forms, maybe civil in the form of a farm structures, irrigation systems, drainage, etc., and mechanical hugely into the farm machineries, and electrical into the irrigation systems, electronics in the form of various electronic gadgets and sensors, IoTs of recent, and computer applications in developing the various IT applications and contributing to the precision agriculture, the AI and machine learning, and aerospace engineering in terms of using the aeroplanes and helicopters and UAVs like drones, and AI and machine learning in various applications. And now, off late, we have started with even a very high what is called advancements in agriculture, such as the robotics in agricultural operations. Then food processing engineering is one section where the post-harvest technologies are also tremendously. So the engineering group has contributed it, and also use of the renewable energy into these things. So they are all many a times they are intermixed. So you see some of the applications with a combination of three or four of these branches. So they might actually look to you that so it is not only a contribution of these sections, but so more or less for the convenience I had divided like this. So I will just tour you through these branches and some of the agriculture structures and the applications in the agriculture basically. Civil is I told you the basic thing I mentioned you like the irrigation system in the olden days and all, and with a very simple farm structures like such as the farm shed, so where to actually store the agriculture equipments and the vehicles into the tractors and other things into it. Now there is a very great evolution in designing the civil structures such as the greenhouse and polyhouses, where we now grow the crops in a protected conditions. So this is a very high advanced engineering technology we can see, where with this kind of the protected cultivation, we can grow the crop within a very small piece of land. There will be a vertical cropping system and so on and so forth. And there is a tremendous increase in the productivity at the crop as we provide the congenial condition for the crop to grow more and more, taking to its fullest potential basically. And we can see a lot of such the greenhouses and the polyhouses in the varieties it has been distributed. So this is one great contribution of the engineers in agriculture basically. Then we also have the very big structures like silos, where for storing the agriculture produce, and also the protecting them from the other insects or the diseases, and before exporting to the various the countries basically. Not only for the crops, we also can design these structures for the cattle sheds, sheep, piggery. Highly advanced structures have been developed, so and being used for a better agriculture production, basically. Then the next important thing in civil is the irrigation. So irrigation, you know that this actually needs a very good engineering technique to manage the water. So very simple way of creating a slope for the flow of water and also from the main channel to the sub channels and all. So we now actually have developed a big irrigation projects like construction of the dams, and then so construction of the irrigation channels for the better water use efficiencies. And also there are various types of the irrigation canals which we can see it now. And because of this engineering technology, water can be transported from one place to the another place, and many of the dry lands have been actually been comes under the irrigation system, which is very essential. As you know that with a lot of the vagaries in the climate, so growing agriculture, I mean the growing crops and then doing agriculture has become highly challenging. However, with the this kind of the engineering technology, by uh, manipulating the water flow, then we have brought a lot of the arid land into the irrigation systems, and that's how we can actually now growing varieties of crops, and also we are actually producing a very high production. We know that India, so now it's a surplus in food production. Though we are now as crossing has become the number one in the population, but still our food production also has increased tremendously. It's all because of the, I can say that the contribution of the engineers in the agriculture basically. Then coming to the next is the mechanical. Mechanical, you know that so this has become a mechanical, which also includes automobiles and all, is inseparable in terms of the agriculture. So right from the introduction of the tractors into, so very big, this such a combined harvesters have now have become part and partial of the agriculture basically, because it's a lot of shortage of the labor in the agriculture ecosystem now. And there's a lot of drudgery which is involved in doing the farm work. Because of all this, the farm machinery has taken a very good replacement, basically you can say that. So now the mechanical and with the automobiles, there's a lot of the innovations which has happened. just from the manipulation of soil, like use of cultivars, blowers, to even the transplanters. Now, yeah, they have designed a beautiful the paddy transplanters, which no need for the people to actually get into the field and then transplant it manually. So where they can actually machines can actually work it out very effectively without wasting the plant, but maintaining a proper spacing, and also so planting it at a proper depth basically. So all that can be actually fine tuned and then being used here. And in western countries, so you know that they are completely depending on these the mechanization, and big tractors and these harvesters have been used, and they have been managed thousands and thousands of single-handedly. It's all because of the automobiles and the machine, the mechanical engineering basically. And not only these, the machines or the automobiles also can be used for spraying the crop, and so that actually increases the efficiency in the proper spraying up of crop on the plant, covering a larger area in a shorter period of time, and also effective management of various biotic stresses, especially caused by the insect pests and diseases. So this is also now here also now you also might have seen that so nowadays farmers are resorted to use of the tractor mounted sprayers, okay, and design their own the tractors for adjusting to the crop spacing and all with a different cropping ecosystem, and they go for it. Then electrical of course cannot be separated from any other branch. It becomes a part and parcel. So I just took it into the irrigation system, where so the lot of irrigation, the improvement has happened. So in the form of the various types of sprays which have been designed like this type of sprays, and also the drip irrigation systems, sprinkler irrigation systems, and the different water use efficiency also into these things. And electronics, now electronics have ruling every field in fact, and the agriculture is no exception for it in fact. So electronics has become an inseparable part even in mechanics, electrical, and as well as the many various other the structures. So we use a lot of the electronic gadgets, and a lot of sensors and IoTs, Internet of Things, for the easy agriculture basically. I'll just go through some of these the things. What are these IoTs applications in agriculture? If you look at, we also now are moving towards a precision farming, and where without these sensors or the gadgets, electronic gadgets, you cannot do the precision farming. In fact, and not only the crop, we can also manage the livestock health, okay, its movement and its consumption rate, etc. And we use these IoTs especially very highly in the protected cultivation, such as in smart greenhouses, where which is like growing the crop in a laboratory. So that is one, and also in agriculture drones. So we use these IoTs and the sensors, and we know that we monitor the climatic conditions through the sensors, and then apply that to the existing crop or to grow the crop on basically. And many mini gadgets have come actually nowadays, which actually monitor the soil health, and in turn monitoring the crop health. So some of these gadgets are very popular and have been used extensively in the which such as is actually a combination of several sensors, and which keeps transmitting the information back to us to look at the soil health and as well as the crop health. In terms of soil health, the soil temperature can be monitored through the sensors, and soil moisture can be at a different depths, so which helps in knowing the availability of the moisture to the plant at the various depths, and also the physicochemical properties of the soil, such as the electrical conductivity, then nutrients. So nowadays, there are some sensors which are now capable of uh, estimating the soil nutrients, the major nutrients like nitrogen, phosphorus, potassium, and also some of the many micronutrients. So based on these sensors, now we will know the soil condition, and accordingly, we can take care of the particular soil or the soil surrounding that particular crop very precisely. Then, of course, automatic weather station is quite popular, and IMDs and the other institutes are using it very extensively as the weather is very closely being monitored. And this is one compact automatic weather station which can be installed on any rooftop which has various sensors, electronic gadgets, which actually record the climatic conditions such as the temperature, the relative humidity, then rainfall and wind direction, wind speed, then photo period, etc., etc., etc. They are very very handy now. All this information can remotely be getting to our the mobile applications, and then know about the prevailing weather conditions very remotely, basically. Now computer applications. So computer applications has now is now it is the world of computer application. You know that. So a lot of the IT applications have been designed, and which actually made the agriculture to take into a newer height. So from a very traditional agriculture to the intensive agriculture to now the precision agriculture, basically. Okay, and with the introduction of the it has further improved in handling the crop or the agriculture situation very, very effectively and easily. So I now actually will briefly tell you about the one IT application that I have developed, in fact, with my team members, which actually is referred as an ESAP. So please don't confuse with the SAP that your engineers normally use it. So this SAP is very different. This SAP means it is an electronic solutions against agricultural pest. Solutions against agricultural pest, SAP. Okay, so this is a very a special IT application with an IT group, so that so we have designed it, and which especially take care of the crop health. So crop health is, that like just like what we get the diseases and all, so the crop also get the lot of the diseases, and also apart from that, the many insects are attacking the crop, and sometimes there's a lot of nutritional disorders also happens. All the three aspects this ESAP is taking care, and it is now being adopted throughout Karnataka state. So to help the farmers in identifying the pest diseases and nutritional disorders on a real-time basis, basically. So what exactly the IT application that it does is that it actually diagnose the crop health in the field itself. That means it has developed a unique architecture. We have developed a unique architecture which actually guides the user, uh, and then after diagnosis, proper diagnosis is happened, then it estimates the problem through the surveying, so to look at the intensity of the problem, and based on the intensity of the problem, then it actually prescribes the solution. Okay, so these are the primary things that the ESAP does it. So it is a mobile application which one actually who uses it so can actually go to the farmer and then handhold him in doing all information which is generated during these kind of diagnosis, estimation, and solution prescription. So all this information will develops into the real-time data, and this mod, I mean reports, and these reports are in multimodal reports which can be viewed by the administrators, scientists, and the policymakers, and who can take an appropriate decision. So it's a mobile-based and web-based application which is coordinated together, and so which is actually helping the farmer to handhold them on the real-time basis. So this is an overall workflow of the ESAP. where you can see the field user is there, and with the help of mobile application he registers the farmer, diagnose the problem, quantify the problem, and give a recommendation. And after recommending it, after a few days they also take the feedback from the farmer, and all this will develops into the reports in the form of maps, then graphs, okay, which can be used by the researchers, departments, and policymakers for the decision support. And this is a knowledge, all the information in the ESAP is the knowledge which is developed by the scientists of all the universities of the Karnataka application. And of course, the IT team is very, very essential in maintaining the software and also the hand holding the people actually. We actually have the information, we can actually support around 52 crops by resolving or solving over 1000 problems which are related to insect pest diseases and the nutritional the disorders. The diagnosis here, what we have done it is not through the AI or machine learning, because we have not um, started yet with that, but it is a simple dichotomous architecture which tells about yes or no kind of a situation. With this kind of a simple architecture, the one can actually diagnose the problem to the 90 to 95% accuracy. There are some applications, if you just look at in the, you will get some of the AI based applications are also there. But of course, right, it needs a lot of the what is called as the database for it to develop very precisely those things basically. Okay. Now moving on to the, there are other IT applications are also there. So you can just Google it out and then look at it. I don't go major into it. There are IT applications which actually looks at the crop production, the irrigation systems, and there are IT applications which actually even calculate the, and there are some applications and gadgets which actually diagnose the what is called as the color intensity on the leaves, and then based on that they diagnose. So like that, so there are so many applications are available. Okay. Now moving on to the precision agriculture, then I told you that. So from a traditional agriculture to the intensive agriculture, like the green revolution that we had, now we are now stepping into the precision agriculture. Precision agriculture is the one which hugely benefits the farmer in terms of using the needy, what is called as the input at the right time in the right place. Okay, in a right way basically. Basically precision agriculture is the use of an input in a right time in a right place in the right way. That's all. Okay, to in order to have that kind of a precision, so we are actually entirely depending upon the engineers, the various sorts of engineers. And this is one the schematic representation which gives that. Here you can see there is a tractor which is running in the field, and this is completely managed by the satellite. So fitted into it, and which sometimes will also nowadays in foreign countries have come with the driverless the vehicle in fact. Okay, so with a very high precision positioning system, it recognizes the each and every plant or the piece of land where it is actually being moving, and there is an automated steering system, and then so variable rate of technologies are there, say in this case. So it is actually the cultivating it, so the land leveling, the cultivations, and everything can be monitored with this. Similarly in a standing crop also, so we do have a very high precision technology can be used. The important the components in the precision agriculture, as you can see, are the GPS and GIS, the mapping or the technology. There's an auto steering, then wireless telematics, as I already told you. Then there is a variable rate of technology. You can see here there's a spraying which is happening. This spraying will actually happen only in those group of or the patch of plants where the deficiency has been sensed, basically. Okay, in that way, so just by looking at one plant which is suffering from a disease or so, oh, so we need not have to go for application of the the chemical or a fertilizer to an entire field. So we can only take care of that particular plant or a patch of the plants basically. Then also it involves artificial intelligence, which actually takes the decision on its own and then so moves ahead. The remote sensing, so through the satellite, actually now it is being operated in the foreign countries, and it collects a huge data, and this data it can be further used for strengthening the decision support system. And also it monitors the yield well before the crop is getting harvested, so the farmer will come to know that how much yield is that he is going to get it. So this is one inner view of the highly precision agriculture tractor, we can say that, which of course is again there is a driverless with the various monitors and the gadgets fitted into it, and which is directly connected to the satellite, and then start operating it on its own with all these the technologies integrated into it basically. And the benefits are huge. I already told you. One is the real-time data on crop status, and also there will be a weather forecast and environmental changes can be known quite precisely. And it reduces the cost of materials and resources huge, because it will be applying only in the place where it is actually is needed. Okay, so there will not be a much contamination. We are not going to spray the pesticides in an unwanted place and then pollute the soil and environment. And it decreases the dependency on the agriculture's weather conditions and increases the production, and also the improves the crop genetics basically. Okay. Then coming to AI in agriculture, now it is taking a lot of contributions in the agriculture. So AI and ML is quite effective, but not made it to a fullest potential. But so there's a lot of scope for the engineering students in making a dent into this field basically. So which actually like you can predict the crop health well in advance. You can make a prediction or the forecast the some of the weather vagaries into it on the crop, or as well as the biotic stresses on the crop basically. So a lot of development is actually happening in these cases basically. The aerospace engineering, we know that since the what is called invention of the aerial vehicles, the vehicles, aeroplanes are also now being used in agriculture, especially for spraying the large area of the crop, like thousands of hectares, using the aeroplanes. And also the aeroplanes are being used to in the forest ecosystem also to control the pest or sometimes the wildfires also. And from this the manned aerospace vehicles to the unmanned the aerial vehicles such as drones. Okay, so here the drone sprays have actually come, and so again there is a lot of potential into this, and you also might be actually heard or seen that some of these drones are now being operated in the farmers field, and there are some the groups who are which are hiring the drone. They have a payload capacity of over 20-25 liters concentrated pesticide, and which covers a larger area in a shorter period of time, and application will be very precise, and the reachability is also very high. And because of this, so it is of very highly useful for the usage in terms of taking a permission in a particular area to be used also basically. And drones are also not only for the spraying and all, they are also being used with mapping and surveying, in fact, and they have been fitted with the different types of cameras, and which actually look at the soil health, I mean the soil health and as well as the crop health. So this is one just a model which has been showing like this drone is actually uh, so mapping a field, and it is looking at the areas which are actually is a good crop health, and it's a bad crop health or kind of a thing. Basically, it's only based on the reflectancy of the light, and that actually. So through satellites we used to do it, but that used to be in a very larger area. Now with the drones, we have now come down to a very smaller areas, and with a 1 acre within a acre, we can actually look at the crop health and then translate that into the and then robotics. Now this is also it's making a lot of the what's called as the entry into the agriculture basically, and still a lot of scope is there for using the robotics in agriculture, especially in the uh, agriculture in the protected cultivation. So fitted with the various the gadgets and the AI into this. Now this particular robot is actually trying to pick a very ripe strawberry in the field basically. So this is a fruit harvest, the robot, and the crop management robot. In fact, so the harvesting, the planting, and then the sensors based, which actually looks at the crop health and all. They are actually in a very elementary stage, but probably time are not actually far away where we start seeing the big machines. In fact, we already now have got the big machines which actually can harvest the fruits mechanically, and also to pluck the cotton. Cotton harvesters have come basically in all those things. And there are some robots which actually also looks at the crop health and then make a very precise spraying, so that the management can actually happen very effectively. Then another section is the food processing engineering. In fact, food processing structures and the machines are now of a high demand, and there's a lot of such innovations, and as well as the investments are being now made, and where after the harvest of the food, now there is a lot of the what is called as the scope for the value addition, and as well as the proper storage, proper transportation, and all those things. For all that, so we need the engineering the departments in order to design those kind of structures. The food processing methods, basically there are various ways, like I told you, right from after the harvesting to the proper processing. Even there are some proper the drying machines are have come, okay, and then there is a proper canning process is come, or a packaging structures have come, and there's a fermentation process in terms of the wine making or many other baking kind of a thing. Then freezing, okay, so storing the food in a cold condition, then adjusting the environment, packaging, then pasteurization, smoking, some adding certain additives into it. All these things actually happens through the machine because it has to happen through a large uh, quantity basically. And this is one the structure which actually is grading the grains based on the size, excuse me, based on the size. And big bioreactors are there, which actually ferment the food, and as well as the other liquid process, and then they can do it. It's why I'm showing all this is that it is only the engineers who can actually design these things for the requirement of the agriculture basically, or the finished products such as this, and all this is being done through the machines, and even packaging also, so which actually done through the machinery things. Then so there is a new the concept in agriculture has is there actually in those which actually we can say that the Israel is the pioneer in doing that, as they don't have the fertile lands, but still they are growing a lot of crops and making it their country a sustainable one. Is like growing crop without soil, like such as hydroponics, so exclusively growing the crop in water. So a lot of designs and the structures have come where without using the soil we can grow the crop, and there is a vertical cropping system has come, and all the nutrient movement and everything happens through the sensors, and the plant will actually not have the soil, but they can grow excellently and then give a very good the yield basically. And not only without soil, sometimes even without air, I mean water also, which is in the form of aeroponics. And see that there will be nutrient solution below, and which actually generates into the form of a mist, and that very fine water molecules are sufficient for the roots to absorb the nutrients and moisture and then grow. So this is all is an engineering technique which actually helps in growing the crop in a very different way. And we have a big structures which are now established to grow the crop without soil. This is one classic example of the aeroponics, and where the vegetables have been grown in a large protected condition through aeroponics basically. And nowadays, the many countries are following this, and maybe the Japan and all, you might have actually seen it or heard that there's a big the farm structures have been developed, and where they grow tons and tons of fruits and vegetables with all this precision agriculture and using the various electrical and electronic gadgets into it. Then we also need the engineers in order to harvest the renewable energy, such as solar and wind structures and the machines, basically. And this is actually happening in a very great the way actually. We have these solar operated the water pumps for the lift irrigation and all, and we have the solar operated the sprayers, and we have the solar operated the crop health managing the things, and we have the solar operated dryers. Okay, so using the solar energy, now the lot of the breakthroughs have been happening, and so agriculture is also getting benefiting from that basically. And a very simple thing that actually we can start with designing is this solar operated sprayer that is already in the market, and where the one who need not have to operate the hydraulic pump for the spraying, but instead so he can actually make use of the solar energy and then go for spraying. And there are some designs made in solar operated the sprayers here also, which also can be connected to the electronic the system, and then remotely you can move this, and those structures are actually coming. Then of course windmills, you know that harvesting the wind energy is also going on in energies can be used in various purpose, including the agriculture basically into it. Okay. And so there are lot many are there in fact, and simply I have taken a few examples out of it, and then just making you to realize that so engineers are very much needed in agriculture, and they have a lot of scope in developing such various technologies in agriculture. You can just think of that anything that you would like to do it there, and then so you can actually start doing it. In fact, a lot of innovations into it. Who actually have imagined that the drones are going to be used in agriculture basically. So this is one such example, and AI is being agriculture, and robots being used in agriculture. So like that, so only the sky is the limit for the human thinking in applying the various technologies in agriculture, and benefiting the agriculture and also to the farming community, and not only the farming community, having a sustainable food production, and also a quality food production, and also safer to the environment than the consumer, and also the various other the what is called as organisms basically. So with this, I close my presentation, and I hope that I have given some insight into it. And thank you for listening, and I am open it for the discussion. Thank you.
Thank you, sir. Thank you so much for this exceptional presentation that you have given. And we, being the non-agricultural students, also, it was in so detail that we were able to connect to each and everything. And you have explained each and every engineering department. So every part of this has been covered. It was very clear, and especially when it comes to the knowledge of, for example, like drone mapping, which you have discussed, and that was really like we didn't know so detailed that AI technology has been into this such deep. And thank you for sharing so much insight, valuable insights, and your knowledge. Thank you, sir. And anyone of you have any questions, please let us know. You can please share in the chat box. And sir, I would like to tell you that the session has been recorded so that our students for the further, actually, if they want to look into your presentation as well as whatever the insights that you have shared, we would like to project that in the form. Yeah.
Yeah. I'm very happy to share my presentation also. I can actually share you to your email, madam, if you give that.
Thank you, sir. Thank you so much. I hope there are no questions on this, and we shall close for the day. Thank you so much, sir. Thank you for being here today.
Thank you. Thank you once again for you and also to your institution. So experience by so to your engineering students, and hope they are also quite interested and benefited with it. Thank you.
Thank you, sir. Thank you all for joining.